Let's discuss an important concept of division of current in parallel resistances. Say we are given with two resistances connected in parallel combination. So these are resistances R1 and R2. And in this situation, if a current I is supplied to the group of these two resistances, we know that the current is divided as I1 and I2 in the two resistances. And if we wish to calculate the value of I1 and I2, the very first thing here we can see is the total potential difference across the terminals A and B of this group can be written as VAB is equals to I, which is the total current supplied multiplied by the equivalent resistance of this group. And for a parallel combination, we can write that 1 by R equivalent is 1 by R1 plus 1 by R2. So in this situation, the value of equivalent resistance we can write as R1 R2 by R1 plus R2. Always remember that for a group of parallel combination of two resistances, we can use the equivalent resistance as R1 R2 by R1 plus R2. So here the potential difference will be I R1 R2 upon R1 plus R2 if you substitute the value of R equivalent over here. Now if this is the potential difference across the combination which will be same across both of these resistances, we can directly calculate the current in R1 is this I1, which can be written as VAB upon R1, that is according to Ohm's law the current is potential difference by resistance. So in this situation it can be given as I R2 upon R1 plus R2. Similarly if we calculate current in R2, this is I2 which can be given as potential difference divided by the resistance R2. If you substitute the value of VAB over here, you can see the final value we are getting is I R1 upon R1 plus R2. So these are the currents. You just keep both of these results as it is in your mind for direct application, time saving applications in different cases. As well as one important thing here, you can see that if we take the ratio of these currents I1 and I2, you can see on dividing we are getting R2 by R1. That implies the current is inversely proportional to the resistance. That means whichever resistance is low, more current will flow through that, or current will always choose the path more, or tendency of current to choose the path more where resistance is less because it can be flown easily. So you just write down a note also here which says that in parallel combination of resistances, current is divided in inverse ratio of resistances. That is, wherever resistance is less, more current will flow through that path. In continuation, we can also discuss the current division among equal resistances in parallel. Say we are given with two resistances which are identical, that is each of value R and R. Now in this situation, we can state if a current I flows into the combination as the two resistances are equal, we can see that current is equally divided in the two resistances, that is I by 2 and I by 2. Similarly, even if we are having a group of n resistances connected in parallel, and if all resistances are identical like this, then in this situation we can say if these all resistances are equal and say the total resistances are 1, 2, 3 up to n, and if a current I is supplied into the combination, then across each resistance we can say as the potential difference is equal, the current will be same, and here among all n resistances current will be equally divided, then we can say that current through each resistance will be I by n. So we can directly state in case of parallel combination of identical resistances, current is equally divided among all resistances. No matter whatever will be the quantity of resistances, it will always be equally divided. Like for n resistances, it will be I by n in each resistance.